Now we are going to see about quantization. Okay, so the quantization is one of the important process in the digital signal processing. So the quantization means in digital signal processing is a process of mapping input values from a large set to output values in a smaller set. Okay, so with the finite number of elements. So in short, we can tell the quantization is the process of converting the digitized signal into a digital signal. Okay, so the best example for the quantization is the analog to digital converter is an example of quantizer. Next one, quantization error. So the quantization error means is the difference between the input value and its quantized value is referred to as the quantization error. Okay, so again the analog to digital converter is an example of the quantizer. So listen, so this is the process of signal processing. It's a process of signal processing. So first we have the analog signals. So the analog signal is converted into the discrete signal by means of sampling theorem, sampling process. So in analog signals, the time and amplitude both are continuous in nature. Okay, so by using sampling theorem, so that signal is converted into the discrete signal. Okay, so in discrete signal the time will be discrete one, but the amplitude will be continuous. Okay, so see the difference between discrete signal and a digital signal. For the digital signal, both time and amplitude are discrete. So now at the output of the sampling process, we have the discrete signals. Again, so now for if you want to work on some digital signal processor or any other digital hardware means they need one finite resistance number. That means it's nothing but the number of bits required to represent the amplitude. So normally this number, finite resistance number, may be limited to 16 bits or 24 bits practically. So we have to bring down the continuous range of amplitude values into the limited values. So for this we are using quantization. So this quantization brings the continuous amplitude into the discrete amplitude. That means it converts discrete signal into a digital signal. So for this we are doing quantization. So we are mapping a continuous range of values. Continuous range of values means the continuous range of amplitudes into a limited values. Here the amplitude. So in sampling process the time only discrete, but due to the quantization process only the amplitude also discrete. So at the output of the quantization we have digital signal. Next final one we have the coding. So this coding converts the digitized amplitude into a binary number. So the output of the quantization will be digital signal. So these digital signals having time discrete and amplitude also discrete. This signal is given to the coding. So this coding converts this discrete amplitude into the binary values. Okay, so this is the original and quantized signal, and this is the quantization error. So next one, for 2-bit number. So we are for the 2-bit number, the number of quantization level in quantization, the number of amplitude level in quantization will be 4. If it is a 8-bit number, means the number of amplitude level in the quantization is 256. Normally the quantization level, the amplitude level in quantization is 2 power n. For 2-bit number, 2 power 2 equal to 4 level. For 8-bit number, means the number of amplitude level in quantization is 256. Okay. So the quantization means is the process of converting discrete signal into the digital signal. Okay. So thank you.